What's up? What's up? It's your man Jimmy Chan. So we're still talking about probabilities here, except these are going to be probability of an event occurring, which would be opposite of it not happening, right? So it would be 1 minus the probability of it not happening. All right. So, and the probability of an event not happening would be 1 minus the probability of it happening. All right. And not happening is also known as a complement of E. All right. So the part that you have to worry yourself about is mutually exclusive. So on mutually exclusive, you see that it is impossible for them to occur simultaneously, so at the same time. So it is impossible for two things to happen at the same time, or two events, I should say, happening at the same time. And these are all going to be or statements, so that's why they're adding, okay? So if those possibilities not possible, then you're just adding the two probabilities and that's it, okay? So what would be a good example of mutually exclusive? Okay, so let's say I was to draw a card, right, off a deck of 52 cards. If I was to draw that card and it says what is the probability of it being an ace or a king? Well, I can't draw a card that's ace of king, right? So since I can't draw a card that's ace of king, that means that these are mutually exclusive because those two things cannot happen at the same time. So king and aces are mutually exclusive, okay? So if it's not mutually exclusive, that means that the two events could happen at the same time. So I'm really still adding these or statements. I'm still adding, except I need to take away the extra, okay? The extra that the two event can occur at the same time. So what is not mutually exclusive? Not mutually exclusive would be like if I was to draw a card from a deck of 52 cards and what's the probability of getting a heart and or an ace, right? So these are not mutually exclusive because you can actually get an ace of heart on a deck of 52 cards. So these would not be mutually exclusive, okay? So that is the biggest part about this, all right? So, and then we'll get into the probability aspect of it. But first, let's hit some problems here, all right? And see if we can talk about these things. So a single six-sided die is rolled. So a single die is rolled. Find the probability of it rolling an even number or a number less than 3. So the question is, can I roll a number that's less than 3 but still be even? The answer is yes. 2 would be even and less than 3. So this right here is not mutually exclusive. So that means I would have to find the probability of rolling it even plus the probability of rolling something less than 3, and then subtract the probability of rolling an even and less than 3. Okay, so what's the probability of rolling an even number? Well, I got 1, 2, 3, 4, 5, 6. Well, 3 of those 6 numbers are even, so that would be 3 out of 6. What's the probability of it less than 3? Well, the only numbers that are less than 3 on the die is 1 and 2. Not 3 because 3 wouldn't be included in here. So there's only 2 out of 6. Minus the probability of getting an even and less than 3. Well, the only number that's less than 3 and that's even is only the 2. So that would be 1 out of 6. So what I have here is going to be a 3 plus 2 minus 1 all over 6, which gives me a 4 out of 6, which reduces to 2 out of 3. So that would be my probability, 2/3. Okay. Now, again, I will say to you this, is that the probability is always less than 1. So if you get something more than 1, then something is wrong. Okay. All right. So you are dealt 1 card from a deck of 52, a 52 card deck. Find the probability that you are dealt an ace or a red card. Again, the question is, can you get the ace and the red card at the same time? If you can, then it's not mutually exclusive. That means you got to subtract that. So I need to find the probability of getting an ace plus the probability of getting a red card minus the probability of getting a red ace. Right? All right. So out of a deck of 52 cards, how many aces would I have? Right? The aces have what? Clubs, spades, diamond, and hearts. So there'd be 4 out of 52. How many red cards are in a 52 card deck? There'll be 26 out of 52, because half the cards are red and half the cards are black. Minus the number of red aces. Well, how many red aces are in a deck? Well, there is only 2, right? Just the heart of an ace of hearts and an ace of diamonds, which is just a 2 out of the 52. So I'll have the 4 plus 26 minus the 2 all over 52. So when I do this, I should get 28 over 52, because 4 plus 26 is 30, minus 2 would be 28 out of 52. So therefore, I'm going to get a 7 out of 13. So that would be my probability there. Okie doke. All right, next one. All right, so the math department of a college has 14, how do I want to do this? 14 male professors, 8 female professors, 5 male teaching assistants, and 12 female teaching assistants. Okay. If a person is selected at random from the group, find the probability that the selected person is a professor or a male. So the question is, can one of those be a male professor? And the answer is yes. It's right here. It says male professor. So it can definitely happen. My first question is, how many people are in this group? There's 14, 8, 5, and 12. So I have to figure out how many total number of people are here. So I have to take the 14, add the 8, add the 5, add the 12, and I'm going to get 39 total people here, okay? So I'm going to put down total. All right, so given the fact that there's 39, great. Now I can go, all right, so I need to find the probability of a professor plus the probability of a male minus the probability of a male professor, since those both can happen at the same time. Okay, so what's the probability of it being a professor? Well, being a professor, you can see that it's only saying professor, right? So that means we got to include the male professors and the female professors. So there's 14 and 8, which gives me 22 professors out of 39. Plus, how many males are there? So it's just wanting males, so let's find males. There's 14 males and 5 males, which gives me 19 males out of 39. Minus the probability of male professors. Well, clearly this says male professors, and there's 14 of them, so minus the 14 out of 39. So what I'm going to have to do is go 22 plus the 19 minus 14 all over 39. So here I will have 27 over 39, which can reduce, right? 3 can go into both. So 9 over 13 is what I have. And there's my probability of it, of that random person being picked as a professor or a male. All right. Okie dokie. So now let's head into probability to odds. So we have probability and then there's odds. Well, there's always odds in favor of something happening and there's always odds against something happening. Well, with converting from probability to odds is pretty easy because in favor of, that means you want the event to happen. So converting it would just be the probability of it happening divided by the probability of it not happening. However, against the event happening will be the probability of it not happening divided by the probability of it happening. So whichever one you pick, that always, the probability of that is always on top, okay? And then odds to probability, so here you'll get a ratio here, and the top is A, the bottom is B, and you'll take those two as your A and B, so the A is on top divided by the sum of those two, all right? So I have a example here. It says the winner of a raffle will receive a 21-foot outboard boat. If 5,000 raffle tickets were sold and you purchased 30 tickets, what are the odds that you are winning the boat, right? So odds are you are winning, or against your winning. I'm going to say this, just say the odds against you winning the boat, okay? So let me actually fix that really quick. Hey. All right. Doesn't want me to do that. There we go. And let's go back here. Okay, so it's against you winning the boat. So it'll be odds against. So if it's odds against, then that would be the probability of it not happening divided by the probability of it happening. Okay? So what's the probability of it not happening? Well, 30 tickets are yours, right? So how about if I put it this way? Probability of it happening is going to be 30 out of 5,000 because there's 5,000 tickets. 30 of them are yours, so there's the probability of it happening because there's 5,000 tickets. The probability of it against you or against the event happening would be still the 5,000, but how many other tickets are against you, right? So wouldn't it be 5,000 minus the 30, right? Which would be what? 49,070 would probably be against you. So that means the odds against is going to be the 4970 over 5,000 over 30 over the 5,000. Okay? And if you copy, change, flip, it's going to be 4970 over 30. And what does that reduce to? So 4970, over 30. Okay, so this is going to be 497 over 3. So only 10 can go into both. So that is your odds against. It's going to be a 497 to 3. All right. Well, I hope that helps. If there's any questions, let me know. Later. Bye.